Alright, hi. So in a previous video I had this light testing machine and I had it connected to a GE controller. This is an older one, of course, but I was using it to test out my light bulb testing machine. But since then I've designed my own PLC, so I'll show that in closer up in just a moment. But I'm going to show overall picture of the whole machine. So let's run a cycle. Right now I have, for bulbs in position, you see there's no light on. So when there's a bulb there, we know it's there. If I'm put it into manual, which is the manual light, this is auto light, this is in cycle. This is all cylinders or all parts returned, like the machine itself. So if I hit a reset, this will reset the motor drive. So I'm going to press this to reset it. You'll see the light go out. Let's do that again. So it's got to be powered. Let's see, let's power it down. This is the motor drive down here. You can't see it, it's off screen, but you'll see. So I'm going to move the slide off of there a little bit, power it up. And it's going to home, lights out. We're getting a full because it took too long for it to get there, so we'll reset that. So now it shows that it's home. Everything's home's ready to go. If things are not all ready, I can't go into auto. So I'll reset manual, try to go into auto. We can't get an auto until we have parts. That way the operators load the machine with parts. Okay, so now we can go into auto. And then I have two buttons here for the cycle start. Again, when this starts, the end cycle light will come on. I have it set, I have a selector switch here set for single operation and continuous operation. So it'll keep going back as long as you feed it with bulbs. Right now we're just going to do one single. This is set up so if anything goes wrong with the inputs or whatever, it'll automatically go to a single cycle. So we're in auto, we have all our parts. I'm going to press the anti-tie downs. So if I press one, it won't work. Press the other, it won't work. Back and forth. You have to press two of them at the same time, and then our warning light for 4 seconds, then we're going to go into cycle. And this is all working on this PLC. These are the outputs, AC. These are the inputs, DC, which can work on either DC or AC voltage. And then we have the sync input card. So it's all positive inputs going into the card. So anyways, let's go ahead and start the cycle. Okay, 4 seconds. And cycle light comes on. And we'll go ahead and pick up the bulb. Test it. And take it to the station, drop it off. And then it returns the cycle light went out. Everything's back to position and we're ready to go again. So let's do another cycle one more time. Pick up the bulb. Checking for bulbs. And it drops out of the cycle and stops. Now I'm going to go ahead and fill a couple of bulbs in here just for test purposes. Okay, we got 3 in there. So now we're going to go to the continuous cycle. And we'll just do the same thing. Start the cycle. I'm going to release the buttons. And I'll show that there's a photo sensor to sense the light being on. I have a light switch down here, which I'll show later, that how if it doesn't I'll turn the power off to this test station, and then the light won't light, so it'll take it to the reject. We'll test that now. So we're going to go ahead and turn the power off to the test station. So now the light won't light, and it'll go to the reject location. So no light. You can see it goes on farther down to the reject station and drops the bulb. Let's turn that power back on again. So this time it'll take it to the good station. The sensor sees no more bulbs, so it doesn't try to release any of them. Okay. And you can see everything is working. This PLC, you can see the LED lights working to show that it's this is actually operating it. So let's put in a couple more bulbs. As soon as I drop the bulb and you see I'm still in cycle, it's in continuous, so it's designed that the operator drops in a bulb and it'll release it. And then continue with the cycle. Stick a couple more in there, just know if we have them. And it'll just continue the cycle and testing all the bulbs that the operator drops in. This is a stepper motor system. In one of my previous videos I showed where I'm actually programming steps, the positions. Like this is position 1, position 2, position 3. Position 1 is the test station, position 2 is the accept chute, and position 3 is the reject chute. So we'll wait for it to, and the operator is going to drop a bulb in, or more. Just for test purposes, we'll just do one. Okay, so now I'm going to hit cycle stop, because I don't want to do any more bulbs. So now you see when it drops its bulb off, the end cycle goes off and it stops, and that's the end of a cycle. So that's basically how the whole thing works. You can see that if the bulb doesn't light, it takes it to the reject chute. And of course the accept chute is much closer, so the cycle's faster. Okay, and now I'm going to show in the video, either I'll show up some close-ups as I'm talking, or show a little bit of it later on, but that's the basics of the whole operation of the machine. I can show different parts and some of the sensors that you'll be able to take a look at. So mainly this is the PLC board. I designed and built this board. You see this equipment on the back. These cylinders were just to a demonstration for my PLC that I built, designed. So these wires hanging out here were actually push buttons and outputs to operate the solenoid valves that make the cylinders go back and forth. But when I wanted to hook this wire up to here, which I said I had originally connected to the ins and outs on this GE controller, I ran, the GE controller used to sit right here, if you look at the other videos. So I removed it and just ran the wires temporarily to the inputs and outputs to show that it actually, that the microcontroller with the I/O boards going 110 down to 5 volts, isolated to operate the microcontroller. This is an Arduino Mega 2560. I'll show it a little bit closer in just a few minutes, or during the video, whichever the case. See what looks best. And other than, so we'll reset it and go into auto. I can send the slide anywhere where I want to go, so we'll go to the test station. You see it'll move to the test station. I can go then to the accept chute, okay, and then return it to the home position. Okay, and we can also go to, I'm not getting an in position because I don't have a bulb. let's just drop the bulb in there to see that. And manual, it doesn't matter anyway, but now let's go to the test station. And then I can do the reject chute. Then you could do any fine adjustments in manual. If there was any to adjust, you want to adjust this chute, because you could drop it down, check it, and say, okay, you want to line it up. Like, it's not perfectly centered, but it drops it in there fine, so I'm not worried about it. And then and again, if it's down and I want to try to send it home, I can't send it home when it's down. It has to be up. So it won't run into anything, then we can return it to the home position. So all of the safeties are kind of built into it. So then as in my other videos where I showed the microcontroller, the Arduino controller being built as a PLC. So this is a close-up of the extra boards. That's the sourcing card. 24 volts. This is the 120 volt AC input card, and this is the Mosfet 24 volt output card, positive output. Okay, this is a close-up of the PLC, the Arduino Mega 2560, working with the PLC, which I'm using OpenPLC to program the microcontroller, the Arduino, as a PLC. Okay, here we are in OpenPLC. You can see in the upper left-hand corner, we're using OpenPLC software to convert the Arduino, or from PLC type ladder logic to the Arduino board. And this is my file, anti-tie down, no timers, light test machine. So I just want to give a kind of an overview of basically how it's working. I'm showing the ladder logics open here. We've got some tags on the side. We have some tags on the side. We have all items returned that we're checking to see that the slide is home, proximity switch, the lift is up, the lift's not down, there is bulbs at the escapement. If there is bulbs at the escapement that can be released, we'll go into all returned. And the all returned is basically is not allowing me to go into the auto mode. If I push the button and they're not all returned this way. This is, as I showed in the video, it won't go into auto mode unless that happens, and that's just the way the logic is written. And then we have our reset out of auto mode, and then we have the manual. And if we're in, then we want to press the manual button, we'll get the manual, and we'll get the manual light. Same way with up here, we get the auto light if we're in auto. It shows us that there. Then we have our anti-tie down section, which is basically checking, which I said has no timers. It's set up to have the output of the anti-tie down, which is down here, that if this is not on and we're in auto mode, we're not able to start the cycle. So the two push buttons, push button 1 and push button 2, are not activated at the exact same time. So press push button 1, push button 2, then we won't fire the anti-tie down, it won't close. As soon as that does happen though, and they're both pressed at the same time, we turn on our warning buzzer. Why is that not showing up? Start cycle, something. There we go. Start cycle buzzer. Never seen that before. Starts buzzing, and then we're do that for 4 seconds, 4,000 milliseconds, and then we
have that delay. When that delay is up, and we're in the auto mode, then we go into end cycle. Okay. So really the first thing we do is when we go into cycle, we want to go down a little ways here to the escapement area. This is the escapement solenoid. So we're looking to see in here that we are in cycle, that there is a bulb at the escapement, and there is no part. So if there is no part waiting to be picked up at the vacuum cup, that'll be true. So this should be true. There'd be parts at the escapement. This is true because there is no part, we're saying. And then if we're make sure that we're up, and the home limit, this is for that adjustment where it backs off the limit, so we're giving it a slight delay to make sure that this has happened. If it does, it turns on the check, and it also starts this timer, which turns this timer on, and we're timing for 0.6 of a second. If that condition is true, then we come up here to timer 6:17. It closes and it fires the escapement solenoid, which is 2.0, output 2.0, and that causes the cylinder to go back and drop a bulb, and the other one come out to stop one. And since there's no limit switches on the escapement system, we're using timers to operate how long it stays back to drop a bulb and then release, and then it gets reset for the next one. And then of course once we release a bulb, then this becomes false here, and we break this circuit. So that's just basically how that escapement drops a bulb. Okay, we'll go back up to the top here ways. Now the next thing we have is the lift cylinder. So basically what we're doing with the lift cylinder is we're seeing we're in cycle, we are at the home delay, the bulb delay 615 is here, that we're just checking to see bulb in position, prox. That's that bulb that we just released. Sorry about that. We just released a bulb. So if that bulb is in position, then we know that, and that timer 15 times out. We close and we send the cylinder down. And so now the cylinder is down, and it's going to have to pick up the vacuum. So the vacuum motor is here, and we're saying that we're in cycle, not in manual. So as soon as, or not in cycle, I'm sorry, the lift cylinder is on, which is here. So we have the lift cylinder is on. If that is true, then, and this timer's timed out, timer 6:01 is, where is timer 6:01? Right here, timer 6:01, because the vacuum cup motor is on. Cup motor is on, and so timer 6:01 is activated, and that shuts off or stops it from starting up again, and we are sealed in. The vacuum cup is sealed, so it stays on running. Okay, so now once that happens, then we know that this timer is set, and we're going to close this contact, but only if the slide is in position, and that hasn't happened yet, because timer 6:01 has got to come up here. Okay, and it's got to where are we in cycle? the move, yeah. Okay, so we're in cycle, it's up, and we're checking for timer 601. Here it is. So we're checking for timer 601 is true, and if we were lifted up, then we're setting this one shot, and the one shot is directly related to this one shot preset. So also again, we're checking to see that the lift is up and it's not down. We pulse, this is a pulse, and we have an off delay timer. So as soon as this energizes, blip goes up and down, then it starts this timer. As soon as it sees an on to off transition, it starts timing. So it goes for 1 second. So the 1 second is how long B161 is on for 1 second. And when that's on, it's saying move to test station. And then if we look down here, down the bottom towards the bottom of the program, we'll see that it's moved to test station will be closed for 1 second, and that turns on this output QX 1.4, and that is to move to this test station. So that's our interface from my PLC to the motor drive, and that sets it to move to that station. So that's basically how the whole thing kind of works. And then, okay, let's, if it is there, we also are turning off the lift, because it went off at the same time, so we're making sure that the lift is up before we tell it to transfer over and out of that station with the bulb. But at this point, we're still in the test position, and then we want to check for we're down, so we have our vacuum seal delay, and we want to test our parts. So what we're doing is we're making sure that the bulb is down in the test station, that we let's see, yeah, test position 2. So this is from the home position, this is the second position. If we are there, okay, then we're down and we're not up. It's going to say the delay test. And what the delay test is doing is we have a pass, bulbs passed, and bulbs failed. And how we check that is once that timer times out, 602, timer 602 times out, we're going to close this contact, and then we're looking at the photo sensor. This is the relay. When the light bulb lights up, this should close. Okay, then we get a pass bulb. But then to make sure if we do get a pass, we're turning off or just making this go false. So when we test for the bulb, we want to see if the photo sensor doesn't go, or the relay doesn't activate because the light bulb didn't light, then we're going to get a false or a failed test, and then that's being held in, and that way it's basically says it's failed. If it's failed, we're going to get the failed contact, and this gets a little confusing, but because of the way the motor controller works, we have to turn on the fail output down here, 1.6, before we make a move, okay, which is timer 603, and that's back down at that move. So timer 603 is going to happen at move. So what we have to do is turn on the failed. So we failed the test. It's in cycle, and we're waiting for the bulb failed test interface to be on. That's our delay. And then we're waiting to make sure that that went first, which is this delay timer here. So if the bulb did fail, then we do the slight delay. So we know this came on first, then there's a slight delay, then this contact closes, which is associated with this coil. When that closes, and we know we're up, and we know we're up because we were up here and not down, so we fired the setup for the delay. Anyway, I had to delay for a second here. Where were we? Yeah. So this contact closes, and then if it's lifted up, we say that the test is complete. And then if the test is complete, we then fire this pulse by test complete B10 170, which then blips that one shot for 100 milliseconds. Again, it starts this and turns on and off, so we do the move. So timer 603, we come back down here. Oh, missed it. Timer 603 right here at the move. You see that timer 603 says move to position. So again, we're firing this 1.4 after we get a relay closure for the fail. Because if it doesn't go before, it'll keep going to the good station, and it'll ignore this so this must come on before the move, or the fail must come on before this move happens. Okay, so then when we get back up to the top, we know that we moved, and we're waiting for it to be home, and then we send it back. Okay. It's a little confusing, but I just wanted to show that the logic does work. The escapement works, the testing procedure works, the good and bad failed parts, turning off and on the lift solenoid. Depending on how we do, we have our manual that we can operate, the lift up and down, as well as the vacuum motor. Manually we can operate it. Push button here. If we're in manual mode, then we can control that. So you can see that the program does run in here. And we've got I have some other things in here that I'm testing for limits to see if the lift is going up and down, and I don't want to I'm going manual move to position, one shot, and then we're checking down here to see if we're moving to any of these stations that we slide moving disable lift solenoid. So on the lift solenoid, the lift up and down, I can't drop the lift or send it down if that's on. So we're double checking here. So B339 slide moving. This way I can't push the down button and send it down while it's moving, where it might crash into something. And we have some delays, timers for checking if the lift is down or up, that it's doing it in the right time, and that's all this sequence in here. So it's a fault, machine fault. We have the light flashing, which I didn't get into. I think it flashed once in the video, but anyway, that's shows that does work. So anyway, it's interesting software that Open PLC designed. to program an Arduino like a PLC, and they have other softwares too besides ladder diagram. If you want to know more about Open PLC, you know, go to their website, openplc.com, and it seems like they keep updating things, and they seem to be very helpful. If there's, you know, problems, they have a forum, so it's quite helpful. And one thing, I'm not hooked up in the shop right now, but if I was, you can use the debug tool up here on the top, and you set everything, communications up properly, and you can actually see the inputs coming on and off, and that's going on and off, and it's very helpful, because I had a problem where the rollers were not adjusted properly after some testing, and I didn't notice it loosened up, and it was shifting just slightly, and it wasn't making the down limit when the lift cylinder would go down, and therefore it wasn't making the switch, so it was just hanging up. And I found that by watching this sequence, the only thing I could think of it was the limit switch, and it sure was, and it showed that it was. So then I found that problem, tightened it up, made sure it was snug, nothing was moving, and it worked perfectly every time. So it's really a nice feature that they put into this software. Anyway, that's a quick overview of the logic. You know, if somebody wanted to know more about the logic, or, you know, how you can basically do this type of thing, I'm more than happy to explain, get into it a little bit further detail. But this is really not so much about the logic as it is that the PLC, an Arduino is a PLC, and the circuit boards that I designed and made for that purpose off of their system. When I saw Open PLC software, I thought, wow, this is really opens a lot of doors, and I can design circuit boards that will take the 5-volt logic and operate 120 volts, and even higher if you really wanted to. So it's very interesting. So with that said, we'll just move on, and thank you for watching this part of it.
The Arduino as a PLC, and then the different cards. So I have the motherboard, which you see the microcontroller connected to. All the pins are soldered on the bottom, so you can see you can get to the reset button. I was able to get this board without the header pins, so I was able to solder them on the back side. This way it plugs in so it faces everything. This has a real-time clock, which I went through in another video, so I won't get to too detail on that. The power supply area. So this is the AC output card, optical isolated, and this is a DC AC input card. So right now it's on DC. You can go to AC and you get the same thing. You can see the light come on, AC. Light come on if it's DC. Okay. This is the relay card. Everything's 24 volts on these cards. This can be whatever voltage, up to 2 amps on these relays. For if somebody wanted to use a relay type of output. And then this is the sync card, which accepts a positive input, so PNP. And we have an NPN board here, which is a sourcing card, so it accepts negative. Then we have the 120 volt input cards, which would plug in either one of these slots. And then we have the Mosfet output cards, which is 24 volt output, a positive output. So that's basically how that works. So now I want to show, just so you can see that the machine, that this PLC is running the machine. We'll go ahead and start the cycle. You won't be able to see me push the buttons here, but we'll put it in the auto. We'll go into continuous cycle, make sure we have a few bulbs, and then we'll go ahead and start the cycle. Hear the warning. turn off the power to the tester, so it'll fail the bulb. Turn the power back on to the testing station. And then the cycle will stop. Or wait for the operator to put another bulb, which I showed earlier. We'll just show that one more time. Dropping the bulb. Escapement releases the bulb. Now I'm going to stop the cycle myself. And this time it'll actually, as I said before, take it out of cycle and stop. So now it's not in cycle anymore. Drop a bulb, it's not going to go. Alright, I wanted to show the escapement. So if I drop a bulb into there, there's a photo sensor right here. It detects that when the bulb is dropped, the red detector you see there. As soon as I drop a bulb in there, it sees that it has it. It'll release it and take it. Shows a couple more bulbs in there. How that works. Okay, here I wanted to show the proximity switches. They're mounted on the side here. You have your up limit and your down proximity switch. You see the sensor or the block that's the proximity switch is sensing. And you'll see as it comes down what's in manual, so we'll just run it down. And now you see that this switch now here is made contact, so it knows it's down. I show you the vacuum cup motor. Basically, this is the little vacuum cup. This is a motor. That's why the cord here. So you can see if I press the button and start it, it grabs it, shuts off, releases it. Limit switch right here, the homing switch for the motor. We'll turn the motor controller on and you'll see that it'll go over and set itself. It goes slow homing. See it trip the limit switch there. This is the testing station. The cone you can see is, in case the bulb's not exactly lined up, it will follow right down into the connection. So we'll do that again, run another cycle. This is the photo sensor that I showed you earlier in the front detecting the bulbs. This is with no bulb. And there's sensing the bulb. Take away the bulb. Sensing the bulb. Manual, you can see the LED come on. The LED is coming on. Then I can also flip it to AC. I show that it's AC, and now the same buttons work for AC. Okay. You see it lights the light, reset, manual, goes into manual. So it doesn't matter whether the inputs are AC or DC. We'll just go back to DC for now. So that's basically the overview of the machine. This is analog things which I don't have programmed in there because there's nothing on here that uses analog at the moment. And like I said, I'll show the cylinder closer. And in the other video of this machine, I did show the video, but in this one, I just wanted to kind of show an overall view that it's actually working with my Arduino made into a PLC with the motherboard and the plug-on input and output cards. So I appreciate you taking a look at this, and hope you enjoy. If you have any questions, I'd be happy to explain how, you know, I built everything was I built here. JLPCB built the blank boards. I did all the design, the layout of the boards, the motherboard and the input and output cards, and then sent them the board. They sent me the blank boards, and I soldered all the parts on and built this test panel just so if somebody wanted to see it or take it, it's simpler than having this a big machine like this. But I had already built this using the GE controller, and I thought, well, this is a kind of a nice way to show that this thing can work a whole machine instead of just two cylinders moving back and forth and moving the block back and forth, which is in another video. If you take a look at that, you'll see it. Anyway, thank you very much for taking a look at it. I appreciate it.